I want you to think there are a lot of differences and nuances between the dynamic routing protocols that exist in the wild today. A lot of those nuances and behaviors stem from the underlying algorithm used by the dynamic routing protocol. Distance vector, link state, and path vector. There's another one you could say for EIGRP, and we're certainly capable of getting in depth on EIGRP. You could also categorize EIGRP, and I'm going to do it on this screen, in fact. I'm going to call that a hybrid. So just like we have hybrid cars, we can have hybrid routing protocols. I'll put that in parentheses right under EIGRP just so we're really confident in all of these. Now, let's talk about distance vector and what that really means. When we're dealing with a distance vector routing protocol, that means that it cares about how far and the direction. That's, in fact, the breakdown of the name. Distance, how far, and vector, direction. The distance, when we talk about distance, a better way to describe that is saying the metric. Because we have other things that could have distance in the name. Let's say metric. Now, do you remember what RIPS metric is? What is RIPS metric? I'm going to say hop count. That's going to be the metric for RIP. So it's simply the number of routers that it takes to get to a location. We'll put the metrics underneath them. EIGRP is not hop count at all. And we're going to see that it is composite. Okay. So let's categorize these, make sure that we understand which ones are which. EIGRP and RIP, they're listed here. Those are distance vector. RIP v1, distance vector. RIP NG, also distance vector. And if you want my opinion, EIGRP could have its own category. Now let's move on to link state. Link state builds a picture of the network. And you could visualize that picture of the network as like a web. And that web is built from interconnects between all the different routers out there, and a cost is assigned to each of these. And then we run the link state algorithm of choice, which is Dijkstra's shortest path first algorithm. OSPF and ISIS both use Dijkstra's shortest path first algorithm, so they are classified as link state routing protocols. By the way, distance vector, the traditional distance vector routing protocol algorithm, is the Bellman-Ford-Fulkerson algorithm. Not like you need to know that. Okay. So, they build a picture of the topology, and then they run Dijkstra's shortest path first algorithm, assigning a cost to those links. So we're going to say cost is our metric for OSPF. And ISIS, it's interesting. The name of ISIS and its metric is called metric. I'm going to just say metric cost because that's a little weird to say. Okay. And then we have, last but not least, a path vector protocol. Now, what does this sound like to you? If someone says path vector protocol, what kind of protocol does that sound like? Does it sound more like link state or more like distance vector? And I'm gonna guess that you said distance vector. It sounds more like that. And you know what? It's interesting because although BGP is hyper advanced, hyper scalable, it's got a lot of bells and whistles, it's not aggressive in its algorithm. And I think that that has been one of the factors that makes this protocol very successful. It does maintain a list of the different autonomous systems. That, in fact, is what it's going to do. So there are a lot of metrics out there, and I'm going to say BGP uses the AS path. It's basically the number of autonomous systems and many different attributes. Okay? So we've got lots of different types of routing protocols, and at the heart and soul is the algorithm that differentiates the brains, the logic of how we compute the best way to get from A to B.